right, so now we're going to start with the rolling blend shape. So getting the tentacle to coil. So I'm going to start by duplicating the geometry here. Move it over to 5 grid units. And unparent this to keep it out here. And we're going to rename this. There we go. Roll B-shaped geo. Now, I will say, admittedly, I have gone forward a little bit, specifically with this setup, because we've encountered a bit of a problem with the rolling effect. And I'll show you what that problem is. I'm going to show you the original method. So if you want to use that, if your model works with that, then by all means you can use it. But I will show you what the problem is here going forward. So to start with, I'm going to apply this as a blend shape to the original. So that is now part of this. There's an old one there. So we'll just turn the old one off and turn the new one on. I'll make sure to get rid of that. So anyway, just to check to make sure this is working. Yeah, okay, so it's working. All right, so the traditional way of doing the rolling or coiling effect is to use the nonlinear bend deformer. So we'll create that, rotate that into position, get it like right near the middle here, bring it down just a little bit, and make sure we rotate it so that it's facing up and down. Okay, let's check the curvature. All right, so it's lifting up and down. Now, first thing, take off the low bound, so it's only starting at that area. We'll take the curvature to 180. And then we'll start to scale it down. Now you see what happens here? How this kind of flattens out? It's because the curvature is only set to 180. So what we actually want to do is if we increase the high bound, then it will keep doing that 180-degree rotation. So you see, if I go to 10, now you see we're getting that effect. And we're getting a nice coiling effect here. But now by default, this works much better if the geometry is flat. But by default, normally, if I coil the tentacle here, you can see what happens to the original. Even if I move it back and forth, you see it kind of collapsing in on itself. Because that's really, by default, it's designed to only curve into itself. So normally what you would do to fix that is you rotate it a little bit. Just a little bit, just so you can get that coiling, that proper coiling effect. And kind of rotate in on itself. Now again, we have that problem here. Some things will help, like scaling it up a little bit, rotating it, something like that. We can even translate it up a little bit to kind of separate it out a little bit. You know, certain things like that. So you can see the effect it's having. Now, the problem is where it might look good. You see how it looks good right here, but as I keep moving it up, you see it starts to collapse more and more in on itself. Even if I were to move this up a little bit, or rotate it, or scale it, no matter what, I'm not going to get a good look throughout the entire tentacle here. I might get it to look good here, but it's not going to look good over here. Or I can get it to look good at the root of the tentacle, but not for the end part of the tentacle. So, and the reason for this is it's because of the width of the tentacle. This would work if the tentacle was the same width throughout. So like the width around here, if it was that same width from the root of the tentacle to the end, this method would work fine. The problem is that you see the width of the tentacle keeps increasing the closer it gets to the main body. Therefore, making the nonlinear bend deformer not an option, because no matter what, we won't be able to get the uniform coiling effect. So that is why we are not actually going to use this. And again, if your character has like a tail or a tentacle that is the same width throughout, by all means you can use this method, and it should work just fine for you. But in this case, we are not going to be able to use that deformer. So I tested a few things out to see if they would work. I tried using the nonlinear deformer and then have an additional blend shape to make the changes and affect the rotation differently at certain parts. I tried using a curve to affect the geometry with a wire deformer and make changes to the curve. That didn't work either. So what I ultimately came up with was a use of a simple FK joint system and a script that will control the rotations of the joints based on the attributes we create. And I will go through that process with you here. I actually found this to be a much more effective way of doing it, and it can be adjustable based on certain things like the width of the tentacle, or like the width if you have a tail and the width is different. This script can be altered to affect different parts differently. So we're going to start by creating the joint system here. And I'm just going to snap to the end CVs here throughout this whole thing to make sure each edge loop gets one joint per set. There we go. I'm going to take all these and I'm going to shorten the radius here, something we can work with. And I'm going to move this to 5 so that it's right in the middle there. That's a helpful thing of trying to keep your blend shapes snapped to kind of grid segments. It makes it easier to replace things like joints. So now that we've got the joints all set up, let's quick rename them. We're going to use the handy dandy script here. So call this CT tent 1 roll. If I rename it. So the only thing we have to do is just change the naming here to waist. So these are normally labeled bind because I use the joint renaming for just a traditional joint rig. So search and replace. There we go. So we got the joint system named. And we are going to do the test bind as well. So I'm going to select all the joints except the N1 for the binding setup. And select the geometry. And we go to skin, bind, skin. Default settings should be fine. So let's test it just to make sure everything works properly. So I curl these. There you go. So you see it's affecting the geometry there. All right, so at this point, what we would need to do is create some attributes on the control. I think I already have them here. Oh, no, I don't. I have an old one, but what we're going to do is delete this and remake them. So we're going to use the script, again, different tool, just to make easy attributes here. So I'm going to call this roll. Reactivate the script here. There we go. All right, so there's our separator. And we're going to do a -10 to +10 attribute. This will allow us to coil from the top and from the bottom, as well as the sides. So I'm going to call this roll up, down for the first one. And then this one is roll side to side. All right, so we have our rolling attributes. Now I can show you the script that we're going to use for this, that I came up with the other night. So, and I'll explain what this script is doing with each line for those that are kind of unfamiliar with Python. So I got this script. This is a kind of a version of part of the script I used for my sticky lips videos. So if you are familiar with my channel, I did a series on sticky lips, and the script I used in there, what that did is it took an attribute, a 0 to 10 attribute, and split up, oops, don't want that. It split up the attribute evenly depending on the number of joints. So in this case, there are 18 binding joints. So it split up the attribute into 18 and then increments those values into a set range node. So when the set range node's value hit that increment number, so in this case, if it's 10 divided by 18, it would be something like 0.55. When the set range hit that number, it would activate a blend shape for a curve, which would affect the sticky lips. So what I did here is adjusted it a little bit. We still use set range nodes, but instead of activating a blend shape with the set range node, we would activate the rotation of each joint here. So as the attribute increases, it will start to activate the rotation of every single joint. Now here's the breakdown kind of line by line, or I'll do it in groups for down here. So the first line just gets us a list of all the selected joints. So got to select the first joint in the system. It'll get every other joint in the system. This gets us the number of joints in the system, and it subtracts 1 based on the waist joint here. If you don't have that waist joint in your system, you can just get rid of this -1. The div value here, this takes that the max value of the attribute on the icon and subtracts it or divides it by the number, and so that's going to give us that increment number I was talking about. So 0.55, somewhere around there. The half value, I'll explain what that's doing, but you can see it's essentially taking that increment value and dividing by 2, and I'll explain what that is in a little bit. Now this list right here, this is a list of the rotation values that I apply to each joint in the system. Now you might be asking, why don't I just be able to use mathematics and just have a simple decreasing number, kind of more of an even decrease in the numbers as the list goes on? Well, the reason why I have a very specific set of numbers here is because the width of the tentacle varies greatly. If the tentacle got thicker or it got wider here consistently, then yeah, I might use that method. But the problem with this tentacle is it has pretty much the same width until right about here. And then when it gets to right about this point, you see there's a noticeable increase. There's a bump in the tentacle, and that increases the width quite a bit. And then it gets exponentially wider right around here. So I couldn't use a specific set of numbers. I had to kind of mix and match and test certain numbers out and see how they worked. And this is kind of what I came up with specifically for this tentacle. So these are the values that we were going to plug into the rotation of the joint system right here. And at this point, we start going into the while loop. The while loop is similar to a for loop, but instead it takes a counting number, and once that counting number reaches a set number, in this case the length of the joints, it will stop, and that's the only way it'll stop. So this I like using this sometimes for if I'm working with a specific joint system, but I don't want to reach the ending joint here. If I want to stop before then, I can do that. It's also an easy way to implement a counter variable here. I know you can pretty much do this with the for loop as well. I prefer the while loop. That's just me. So the first lines of code here, ignore those errors. It's just a script editor being annoying. So the first four lines here, these are creating the variables. So it's creating the set ranges that we're going to essentially convert the attribute to the rotation values. We got one for the z-axis and one for the y-axis. And then we have plus minus average nodes, so we can add together the positive rotation coils, coiling. So when it coils up, it's the positive numbers, and when it coils down, it's the negative numbers. And we're just going to add those together using the plus minus average node. The next couple lines, the next few lines, we're dealing with connecting the attribute of the icon here into the set range nodes. Just basically the same attribute twice, one for the positive, one for the negative, same for both attributes. From here, this is that increment value that I talked about. So we apply that increment value to the old max x, since that's the value of the attribute. We add 1 to the counter, so that when it's at 0, so we don't multiply by 0 with the counter, we always add 1 to it. And you'll notice I use min here for the y, because when we're dealing with the negatives, the lower value, meaning the higher negative value, is the minimum. So in this case, for the positive, it would be old max or old min 0, old max the increment value. For the decreasing, the old max would be 0 and the old min would be the negative number. I know it can be kind of confusing, but that's how the set ranges are. I'll show you all that once I actually run the script. So we set the old min / old max here, depending on the positive and negative. So for the positive value, we set the old min, which is typically, at least for the first one, it's 0. And for if it's negative, it would be the increment value. And this just makes sure that if it's 0, we set it to 0, and otherwise, what we use here is we take so essentially, when I wanted to set it up, when I initially did this without the half value here, when it started to rotate, it would rotate fully, and then it would kind of pop, and then it would rotate, the next joint would start rotating, and then it would pop, and then it would keep popping once the max rotation was reached for each joint. So what I wanted to do is create kind of a smooth transition from one joint to the next. So that's what this half value is for, is essentially I start the rotation halfway into the previous joint's rotation. So when it's 0, I don't want to do I'm not starting it with the half value, I'm starting at 0. But outside of that, I start at the half value. So if the increment value is 0.55, then this second joint here would start rotating at like 0.225, something like that. So that's what the half value is for. And then we set the min and the max for the rotation values for the joints. So by default, it's 0 here for the rotations, and then the rotation values for the positive is just essentially going through this list here, and we just set it to we multiply by -1 for the negative rotations. Then we connect the out value of the set ranges into the input 1D of the plus minus average nodes, and then we connect the output of the plus minus average node into the rotations of the joints. And then we just increment the counter and the joint counter. I use a separate counter for the joints so that I'm not, because typically the counter would start at 0, which would be this joint. So I have a separate counter that starts at the second to last joint and counts down. So that way I'm connecting everything from here back. So that's pretty much the script here. We'll run it real quick just so you can see what it's going to do. So run the whole thing. So if I run the attributes, you can see what happens. So you can see the coiling effect. Don't worry about the body caving in. This is just a test bind I'm using just to make sure that this is moving in the right direction. But you can see it's not really intersecting anymore. We're not getting any intersecting geometry. It's a nice tight coiling of the tentacle, which is exactly what I wanted. And if I move into the negative, you see it curls the other way. Now you'll notice here, we do get some spacing here. The reason for that, if I open the script editor again, it's because I'm using this specific set of values was used for the positive rotation. So however wide the tentacle was up top, it might not be the same in the bottom. So you may want, if you intend on using this, you may have to have a separate list for the negative rotation as well. Similar for the side-to-side rotations. So if I move this side to side, you get a similar effect. Now you might not necessarily want a side-to-side coil because the tentacles are pretty close to each other, so you might get some intersecting geometry anyway. But I wanted to show that this can be done using a side-to-side effect as well. And what's also nice is if we wanted to, we could also take the joints here and we can rotate it in X, and you're able to kind of turn the coiling a little bit. So you can get a nice little effect there, which can be used for both types of movements from side to side and top to bottom. You can get that turning effect. So if you wanted to, you could set up an additional attribute that says turn coil, and it will rotate it in X. And so you can get that effect as well. In fact, you know what? Let's do that. Let's have some fun with this. So an attribute, say turn coil, -10, +10. Okay. And we're just going to use a simple set-driven key for this one. It's a lot easier to do it that way. So set-driven key, load driver, turn coil, and we're going to rotate X. Close the script editor here. So if I set this to 10, we'll select all the joints here. Make sure I got them all. And we'll do something like, let's say, 60. We can push it. We can always dial it back if we need to. And do the same for -60. Key it. And there we go. So we can roll the tentacle up. and we can turn the coil. We can really push this if we want to. You can see we can get some pretty fun coiling effects here. And it works with the negative, well, from the side to side as well. Pretty cool, right? So that is creating the coil for the tentacles. I'll bring up the script again. So if you guys want to use this, you're more than welcome to. I'm leaving it here for you guys. It's a pretty basic script, but it can have a lot of applications. So if you want to use it, go ahead. But that is the coil. So at this point, we're going to move on to the squashing and stretching blend shapes. All right, so before we start with the squashing and stretching shape, I just want to clean up the roll shape here. So I'm just going to parent the ribbon and the joints under that and then hide it. So we should be good there. All right, so let's start with the squashing and stretching. Now, as I'd explained before, we're actually going to do two different squash and stretch shapes. We're going to do one based on, push this one all the way to 6 there. So we're going to do one kind of generic stretch, which is going to stretch the entire thing together as this control stretches the tentacle. And then the other one we're going to do kind of like a mid stretch where this control here in the middle, depending on where we push it, is going to dictate which part squashes, like right here, and which part stretches, like right there. So we're going to do two different types of stretching. But for the start of this, we're going to do the kind of generic stretching. So let's start by cleaning this up and naming everything. I'm going to call this SQST1 for squash stretch 1. All right. Now to do the squashing and stretching here, we are actually going to do a squash deformer. So we go nonlinear, we go squash, and there we have it. So one thing I'd like to point out before we move on from here is in order, because one thing I want to do with this squashing and stretching is connect it to the existing system here. So as this control moves out, the tentacle stretches. So in order to do that, because we already have this handy dandy little distance tool that we used here in the original setup for the ribbon, we have this distance variable, which is exactly what we need, because this is the length from the root to the end of the tentacle. And the easiest way to set this up so that it'll squash and stretch with the existing rig is to actually make the handle here the exact same length as the stretching. So we have a 1-to-1 ratio there. Because by default, the handle here is set to a value of 1. So if I move this to 1 and I turn the negative off, you can see that roughly the handle here, you can kind of see it. If I were to grid snap it here, that would help. But you can see that pretty much the handle is exactly 1 grid length. So that's the default kind of length of the handle, and especially since we want to turn the low bound off. So what I want to do is, yes, before I do that, I want to get that scale value back. So now I'm going to turn this to 0. I'm going to move this back. And now I want to set the scale value here of the scale y, because that is the one that is going to be scaling here, I want to set it to precisely what the stretch or what the length of the distance dimension is here. So there's a few ways if you want to get the exact value. The easiest way is to use just a simple getAttr command with the script editor, and then just print the value, and then it'll give you the exact value. Or if you want to, you can build that into a tool like I have right here. So I'm going to take the shape node, go down one, load selectable adders, ignore the error, and we scroll all the way down to the distance right here. So here is the exact distance value. So what I can do is actually take this value, and we're going to use that for the scale y here. So if I plug that in right there, now you can see it is pretty much exactly the same length. Now I can move this down, and I'm probably going to, so that it's not going to cause, because sometimes with the squash and stretch, if it's not perfectly in line with the handle, you know, parts that are above it will kind of move up a little bit, and parts that are below will move down. So I'm trying to keep this as in the middle as I can. All right, so and having that scale value is really going to help when we actually set up that squash and stretch. So the next phase of this setup, because we have it working already, you know, we are getting the squash and stretch that we're looking for. Now we need to be able to apply a stretch, the value of this stretching to something that the joints can use. And the way to do that, the traditional way at least, is to apply hair follicles to the system. So we go to FX, we go to N hair, create hair. Should be the exact same values that we had before. Create hairs. So we got our hairs here. We have 18 of them. So what we're actually going to do is we're going to take those output curves, delete them, take the hair system, delete it, and the nucleus too. We don't need any of that. So now that we just have the follicles, so if I expand this, now you see they still stay in the middle. That doesn't really help us. So what we're actually going to do is take all of these follicles, and we're going to move them over. So what we're going to do to get these follicles to the side here is we're actually going to mess with the U parameter here, since that's at 0.5. I can either set it to 0, let me set it to 1. That way it could be in the positive. So now that we've got it at 1, if I move the factor here, you can see the follicles are following down the edge there. But more so, I can now calculate the distance from its original position to the center, and that is our stretch value. So real quick, I'm just going to rename these. I believe this is the naming that I had for them. Let's try and do this as fast as humanly possible. Because I don't really like having the numbers at the end. I like having what is at the end, the actual suffix. That's always just been a personal preference of mine. Because I don't just like using the generic numbering sequence that Maya has, because it puts the numbers at the end. All right, so just a few more here. Okay, so now we have all of the follicles here. We have this named. I'm just going to call this follicles. There we go. All right. So now we just need to calculate the numbers here. So the way I want to go about doing that is what I want to do is, I know that the center of the ribbon is at 6. So if I look at each follicle here, you can see that number is 0.135. That's what I want to isolate here. So what we're actually going to do is set up a series of nodes to hook this all up. So I'm going to start with the last one here, and we're going to connect it into the scale X and scale Z of the binding joint here. So we're going to open up the node editor. We'll add these two things in there. I don't need the shape, I just need the follicle. So what I need to do is subtract 6 from this follicle number to get the distance. So easiest way to do that is with plus minus average node. Name this really quick. Call this plus minus average. All right, so we'll go into the input 1D here. Translate X. Now I still can't get the other value here, so a little hack here. I think I've already showed this, but I'm going to hook it into the second attribute here and then just delete that connection. So it gives me the second number right here. And I'm just going to hit 6, and we're going to convert this to a subtract operation. So that'll do it. So now we've got our connections. So now we've got the number, that 0.135, and we need to hook this up into the scale. So, very similar to how you would normally do a stretch, is we are going to take the distance here, or that remaining X value, and plug it into input 1X. And what we need is that default 0.135 value. So again, the way to do it simply is using a getAddr command in the script editor, or if you create the tool like I have here, getAddr, load selectable, so this is translate X. So I don't need the 6 here. All I need are the remaining numbers after the decimal. So all I can do is just copy that and plug that into the multiply divide into input 2x. So there's our exact number. And then rename the multiply divide here. Okay. And make sure to set the operation to divide. And there we go. We'll probably need to set something up for when we actually make this scalable. We don't actually have to multiply the stretch value, I don't think, because this is going to be outside the hierarchy, so this isn't actually in a scale. Well, we may have to plug it in between the connection to the joint here. So, but for now, we'll plug this into the scale X and scale Z. And what we can also do is have that on-off switch. So what we can do is plug this in to a multiply divide, just like this. And what we can do is key this input 2x between 1 and 0, or we can just directly connect it if we use a Boolean attribute. And there we go. So I'll just call this on off. And there's a million ways that you could do kind of an on-off switch with nodes. You can use any range of nodes. You can use the blend colors. You can use the set range. They're all options here. You can kind of pick which one works for you. So we're going to plug the output x into the scale x and the scale z of the joint. So now if I actually move the factor here, you should see it is connected, so that's good. And you can see, it's very hard to see. You can, if I adjust the factor here, you can see it's actually squashing and stretching there, which is perfect. So at this point, we can go through and connecting everything else. So I actually have a script to do that for us. This script down here is pretty much everything I just did, with the exception of the on-off multiply divide. I just added that in. So what I'm actually going to do is, so I'll just call this OO name. So what I'm doing here is just creating the plus minus average node and the multiply divide node and getting the names for everything and just literally connecting everything in. Literally everything I just did is in this script. So you can kind of take a look for yourself. So there's the name. Let's create the next multiply divide. Okay. And we need to connect adder from the multiply divide node. So this is, there we go. Connect the output of the new MD into OMD. By default, the input 2x should be 1, so we don't actually have to set that attribute. And then we just connect. Oh, wait. Just need to replace the name there. And that should do it. All right, so we now should be able to run the script. One thing I always suggest when you're working with scripts, please save before you do it, especially if you've made changes to the script, because if you're not careful, something really bad could happen and you could lose a lot of work. So always make sure you save before you run a script. So I did the setup for the 18th follicle. I just need to do it for the other 17. I don't know why it's really weird. The mouse is acting up. All right, there we go. Select the other 17. I think everything is looking good here. Yep. So run it. And let's check the squash handle to see if everything's working. So it looks like it is. Now I notice the follicles aren't moving quite the way they were initially supposed to. But the way I look at it is, as long as they're doing what they're supposed to be doing, then it doesn't really bother me. As long as they are scaling the exact same way, then it doesn't really bother me. So, the second that they don't start working, that's going to be a problem. But for right now, they're doing what they're supposed to be doing. So they're not translating in Z anymore, despite the fact that they are connected. They're not translating in Z, but they are translating in X, that's the important thing. So sometimes the follicles give me issues like that, but again, as long as they're working the way they're supposed to. As long as the main ribbon follicles are moving the way they're supposed to, that's all that matters. But these ones on the edge, it's okay. By the way, let's name this squash handle before I forget. I'll call this all squash. All right. So now what we have to do is connect this distance dimension into the factor of the squash handle here. So since everything is the same length, this is going to be a lot easier than it would have been before. So we'll actually add these in and actually want the shape nodes for both of these. It's the rare moment where I don't need the actual object nodes. So all we really need here is a simple scaling setup. And I'm also going to include the move all icon, because this is one where we definitely need to have it scalable, because this distance, it will scale with the rig. So the typical scaling setup is we need 2 multiply divide nodes. We don't normally, a lot of these would have like a condition node or something like that, but since we are doing squashing and stretching, we don't need a condition to say only stretch at this point. So let's connect it in. So I'm going to take, we'll plug the distance into input 1x here. Now this would also help for the second multiply divide node, because this is the one where we multiply it by the scale of this master control icon here. So if I go scale, you can pick whichever one you want. So just go scale X. So what I need here is actually the default value of the distance dimension. So this is again where we would need a get adder command to get the exact distance here. So we can be a little bit more precise here. So we now have the exact distance of the distance dimension. We plug that into input 1x. And then we plug this in the output into the input 2x. Make sure we set this node to divide. Let's name everything before we forget. So CT tent 1 SQ ST1 Let's call this all squash multiply divide. Actually, we don't need to put the all squash since we have the SQST1, but we need to make sure that this is we identify this as the local scale. There we go. So this is the local scale multiply divide, and this is the global scale. All right, so the last thing that we need here is we need to subtract, because right now we've got that scale value set to 1, but the factor of the squash handle starts at 0. So what we actually need to do is just simply subtract 1 from that scale value. We'll call this plus minus average. There we go. So we're going to plug output x into the first block of 1D, or the first setting of 1D. And to do that trick again, we're going to plug it into the second one, delete the connection, and there we go. It's already set to 1. The only thing we have to do at this point is set it to subtract for the operation, and then plug output 1D into the factor. And that should do it. So if I move this around, you can see that we're getting an accurate stretch relative to the tentacle, relative based on the distance of the tentacle. And one thing I'm going to do is I'm going to turn off that tentacle bend so you can see it squashing as well. Now, one thing I'm noticing as I see the squashing here, it doesn't really, you can see it from the blend shape, it's not really squashing all that much. So one thing I might want to do is actually push that a little bit further if I can, because this is based off a distance, and the factor here on the squash handle, it actually goes to the negative. So if you want that real squashing value, it really has to go into the negative, and it's only going into the negative ever so slightly here. Yeah, like it's only like 0.5, which isn't really a whole lot of stretch value here. So what I'd like to do is push that just a little bit further if I can. So the way we're going to do that is we're actually going to add a couple of nodes here, and more importantly, one of them is a condition node, so that when it stretches, we're getting the normal stretching that we've already achieved here. But if it's squashing, push it a little bit further. Now the advantage here is I have this set up so when it's at, by default it's at 0 when we plug it into the factor. So I can say, using the condition node, if this goes under 0, meaning it's a negative value, I can multiply that negative value so I can actually push the squashing a little bit further. So first thing I'm going to do is I'm going to create a multiply divide here. So I'm going to call this squash adjust, and I'm going to plug the output 1D of the plus minus average into here, and I'm just going to multiply it by 2. That's really it, just for the squash adjust. And then we're going to create the condition node. And there we go. let's see. There we go. So we got the squash 1 condition. So I'm just going to say if the output 1D of this plus minus average into the first term, and say if it is, I'll say if it's greater than 0, then use the traditional scale value. And if it's less than 0, we're going to use the output X here. Plug this into the color if true, false. There we go. And now we'll just plug the out color R of this condition into the factor. So let's take a look and see what we get. So if I move it out, normal stretch. If I move it in, you can see here we're getting a little bit more squashing here than we did before. The follicles, they're acting up a little bit. We'll just hide them, but they are still working, so that's the important thing. So you can see here we're getting a little bit more, and you could adjust this squash value if you wanted to. So if you really wanted to push it, it's not going to look that good, but if you really wanted to, you could push it to 3. I think 2 is about as far as we want to push it. And again, you could create an attribute to adjust that amount if you wanted to. But more importantly, that should be all that we need for the squashing and stretching here. So it's looking pretty good. So I would say that now we're officially done with this part of the setup here. We just need to connect the attributes in for the squash and stretch, and then we should be good, because all that's really left is some of the adjustments here on the squash handle. So like adjusting the position here. And we could even, if we wanted to, we can key it so that we can actually get this nice rolling effect of the squash and stretch if we wanted to, kind of inflating and deflating like a balloon. You could also do that with the scale as well. It might actually be better to do it with the scale here. But the max position here is the one that we really want to work with. So at this point, all that's really left to do is to have some attributes to control the just the other minor things here, like maybe connecting the envelope so you can turn this squash and stretch on and off, adjusting the expand position using this expand attribute as a multiplier. So that's really all we would need to connect this together, is we just need those 3 attributes. We might also include one if we wanted to move the handle. So if we really wanted to, we could try scaling the handle, or better yet, we could try translating the handle. That might give us some better results there. So we'll test it all out and see if it works. So the first thing I want to do is get the attributes here covered. So the envelope, the expand, and the max expand position. So those are the ones I want to start with first. So we'll start creating some attributes. So I'm going to reload the auto script here. So I'm just going to call this all squash for the separator attribute, and then we'll create some attributes here. So for the starting one, the on-off, I'm just going to use a Boolean attribute. It's just a simple on-off attribute. So I'll call this all squash on off. And so there we go. And next we want the expand attribute on the squash handle. So I'm just going to call this a multiplier. So I'll do all squash multiplier. Now the reason I'm naming it this way and using all squash in front of it is because we're also going to have a second squashing and stretch blend shape here. So I don't want to just name it multiplier because I might use multiplier later for a different attribute, and I want to make sure that these are uniquely identified. So this one I'll mark as -10 to +10, and then the last one is we'll do all squash position, and we'll add attribute. So we'll start with that for now, and then we'll look into adjusting the handle after that. Alright, so now we're going to start connecting the attributes. So I'm going to select the main icon with my attributes on them and the squash handle here. And I'm going to load them into the node editor. So what I'm actually going to do first is I'm going to select the squash handle and just graph that out. Because one thing I need from the squash handle here is this little node right here, squash 1. This is the actual kind of the math of it. It's not the shape handle, it's the actual squash node, like the math node, the deforming node. So this is actually what's going to give me what I need as far as the connections. So now with that, I can select the main icon here and add that in. There we go. So I can take the all squash on off here and plug that right into the envelope. So now if I move this around, just to test to make sure everything works, see we're getting, you can see the stretching here, and if I select the icon and I turn that off, you see we get the switched on off. So we know that it's working and we're connecting to the right node. I'm just going to zero all that out. So now we need to connect into the expand here and then the max expand position. So what I'm going to use, since I'm connecting two attributes into here, I'm going to use a set range node instead of a set driven key, just because I like set range nodes better. So I'm going to plug in to this node the all squash multiplier and the all squash position, and I'll call this, let's name this here, CT tent1 all squash adders set range. So both of these attributes here are -10 to +10. So plug those into the old min here. And the old max should be 10. So for the first attribute, which is the multiplier, I'm going to stick between the range of 2 and 0. The reason for that, it's actually better if I show the squash here. So if I show the squash here, and I click on the handle, and I click expand, well, maybe, you know what it is? I directly connected the attributes in. So once it does that, it kind of negates the attributes here. So I gotta just connect these in. But just know, and you'll see why. We're gonna stick with a min of 0 and a max of 2. And then for the all squash position, it goes between 0 and 1. But it doesn't fully go to 0 and 1. It goes 0.01 before it. So the min z is going to be 0.01, and the max is going to be 0.99. So we'll plug both of these into the expand and the max expand position. And that should do it. So let's see how it looks. Sure everything's on there. Yep. So if I plug this in, so let's check the attributes. So if I check the all squash multiplier, it doesn't work. Squash position. See, that actually does work. That's good to know, so I'm not going crazy here. So why is the expand not working? Interesting. Well, it was working before, but this is a good chance to kind of think outside the box here. Let's come up with an alternative solution. Normally, I would connect it directly into the expand. It would work fine, but for some reason, the expand just is not working here. Even though I've connected it correctly, we're getting no change. We should see a noticeable difference in the connections here. But nothing is working. Everything is connected correctly. So now we need to come up with an alternative. And my first instinct here is to have the multiplier actually run through the factor here. Let me just double check something. If I turn the multiplier to 10, yeah, the expand is set to 2, so it should be working. But, so what I'm actually going to do, I'm going to do something a little different. I'm going to plug this into a multiply divide right before we plug this into the factor of the stretch handle. So, what I want to do is take these two things, expand the selection. So let's see if we can get the factor here. All right, so there's the final node before we connect it into the factor here. This subtracts the 1 and converts it into 0. So we're actually going to create one more multiply divide node. And we are going to connect the output 1D into the input 1X here. And we'll take the output Z and plug it into the input 2X here. And so we're going to set this up a little bit differently. Actually, no, we wanted the output X here. Output X into input 2X. There we go. Yep, because it's set to 10, so it'll multiply it by 2. And then we'll plug this. Let me name this first before we go crazy. QST, pull this multiplier. And multiply, divide. And we'll plug the output X into the factor here. So you see we're actually getting a little bit more. Yeah, it's no longer moving with the control, like it's not getting the same length, but that doesn't necessarily matter. I just want to multiply the amount of stretching that we're getting. So even though it's a different length, we're still multiplying the value. And I could always, if I wanted to, shut this to 0 and we get the default amount. And I could shut it down to -10 and it completely turns it off. So we have those options there. So with the expand no longer working, what I'm going to do instead is I'm going to take, wait a minute, don't do that. I'm going to take this expand attribute that was there and just disconnect it just in case. But that should do it for connecting the attributes together. So we've got our multiplier, and we've got the on-off, and we've got the squash position. So it's looking pretty good here. So we've got the attributes that we want. Now, I'll take a look and see if moving the handle is actually worthwhile. So if I were to squash it in here, let's see. You get kind of a nice ripple effect here. But honestly, it doesn't seem like enough of a hassle to make it work. But just know, if you want that ripple effect of the squash, like if you want to have it kind of, the squash like fall back in a certain way, or you want to go in the reverse direction, you can always move it here like that. Either way, you have options to do that. I don't really think that's all that necessary for this, but just know if you wanted that to be the case, you can move that right here. But for right now, I like what we have here, so I'm going to pretty much call the all squash here a wrap. And so we'll get started on the second type of squash and stretch, kind of the mid stretch here. So we'll take a look. So we'll get started with that next. All right. So before we start with the the kind of mid squash and stretch setup, I just want to clean up everything here first before we get started with that. And we'll just take these three things and plug them underneath the all squash pad there. And we'll get started on the next one. So if I just duplicate this one, actually, just to be safe, I'll duplicate the original. I don't know why all those attributes got hidden on it, but alright, well, doesn't really matter. I'll just duplicate it, and this will unlock and hide and unhide all of the attributes there. So we'll move this all the way over to 7. All right, I'm going to unparent that. I'm just going to name this SQST2 V-shaped geo. All right. So, like I'd said before, this is going to be a squash and stretch that's going to work in two different parts. It's going to work where there's going to be a control in the middle that is going to be moved by the control here, and the distance between the center and the endpoints here is going to drive two separate squash and stretch handles. So the first thing I'm going to do is we'll start just by creating the squash and stretch handles. So go deform, new squash, and this is a quick hack here. I'm going to do an orient constraint with maintain offset off to kind of get it into the correct orientation position there. Turn on the factor here, turn off the low bound. All right, so we got the one for the top half, for the upper section of the tentacle all set here. So what I'm going to do is kind of move that right into the middle. So I'm going to just vert snap right on that edge loop, move it over to 7. And what I'll do is I'll reorient this so it's right pointing at the edge there. As close as I can. You see, it's not fully reaching the edge, and we'll get to that in a second. But in the meantime, I'm going to create the other nonlinear squash on the same geo here. I'm going to do the same orient constraint up there. So what I'm going to do here is up the factor, and I'm actually going to turn off the high bound. And I'm going to snap this. Same thing to get it right in the same spot. Snap it here. And then rotate and bring it up. So it's pointing at the edge there. I may actually even move this down just a little bit. There we go. Okay, now you'll notice that these aren't really reaching the edge here, and I want these to have the exact length of the kind of sections that they're supposed to be mimicking, because that'll make it easier for when we set up the squash and stretch based on the distance, similar to what we did here, how we used this distance dimension here to kind of drive the factor here of the squash handle. So to do that, I'm going to need some distance dimensions. So we'll use the original setup here. So I'm going to using the distance dimension tool here. So if I create measure tools, distance tool, I'm just going to use grid snapping just to make two sets real quick. So if I try and make it here, there's a locator here, and sometimes they combine locators, which I don't necessarily want here. Okay, so we got our two distance dimension tools here, or distance dimension setups. So I'm going to snap this one right on top, right in the middle. There we go. Put this one right in the center here. There we go. We'll do the same for the other two here. 1 and 2. Perfect. All right. So you'll notice if you look at these distance dimensions right here, you see they're at 1.39, and if you look at the handles here, they're 1.36. So that's that little change in the measurement here. That's the real difference here. So what we're actually going to do is we're going to take these exact values, and we're going to plug them into the scales, or the scale Y of each of these handles. So before I actually start getting the attributes and plugging them in, I just want to name everything first before we get to all of that. So I'm going to call this CT tent 1. I'll call this up squash root locator. And we'll call this up squash end locator. We'll call this up squash distance dimension. And these are the low squash. Okay. Make sure I rename everything here. All right, so we're going to call this the low squash handle. And we'll call this the up squash handle. All right, so now that we've got that, now we can start to plug the values of these distance dimensions into the scale of the squash handles here, so that it'll kind of stretch properly based on distance. So the way you do that is you can either use a Python script, the simple getAttr script, and just print that out to get the exact number, or you can use a handy dandy tool like I have here. Make sure I get the shape node, load them in here. All right, so there's distance number 1. So that's for the upper one, so I'm going to plug that into the scale Y. And now you'll see the handle pretty much reaches the exact end of the ribbon there. So we'll do the same thing for the other one. Get the shape node of the distance dimension. Get the distance there. There's the exact number. Plug that into the scale Y. So now you see it reaches. So now we've got perfect measurements there for the squash handles. All right. So at this point, what I'm going to do is I'm actually going to move the distance tools over to here. So I'm actually going to take all these and type in 7 so that they all move exactly right here. Because I don't necessarily want to use it. I want this to activate the squash and stretch for each part. I want to activate it only when this middle control moves. Because we've got the main squash handle here for the master, for when the whole thing moves together. I want this to only be activated once this control moves. Because these don't really work together, so I can't just use these two for the entirety of the squash and stretch. So I'm trying to use both of these together. So I only want to activate this when this control moves. So I'm going to keep these on the blend shape here. Now the next thing I need is a control, or at least something to connect into these middle locators, so that when I move these around, you see the distance moves there. So you can use an icon if you want. I'm just going to use a little circle control here. And what I'm going to do is I'm going to group that circle. And then I am going to use that middle control, because the middle control has kind of a specific orientation. We see how the x-axis is pointing outward. So what I'm actually going to do is just select this control and then this group here, and I'm going to orient constraint with maintain offset off, just so it snaps there. And then I can take this control and move it to the center here. And if I want to, I can scale this thing down just so it's not so obnoxiously large. And freeze transforms on it. So I'm going to call this CT Tent1. I'm going to call this mid squash control. I don't want to, this is important, I don't want to name it icon, because the main controls here for the rig, I use the suffix icon. So that way if an animator wants to select all the binding control or all the main controls in the rig, they can use the underscore icon. Anything I'm going to use as kind of a reference, like on a blend shape rig or something like that, I always use control, just so that I don't mix them up. And I'll just call this control pad. All right. Next, I'm going to point constrain the mid locators here. Let me just use quick constraint here. All right, so if I move this around, it's now moving the distance tools. That works great. So my first instinct, your first instinct normally would be, all right, well, let's just directly connect these in. So we can use really whatever you want as far as connections go. I like using the connection editor. It's a little old school, but gets the job done. So we've connected it in. So now you see it's moving. Now the problem is, this all works well and good. The problem is, I'm actually going to hide this setup. So I forgot to clean this up. I cleaned this up previously, but Maya froze, so I had to redo this. Okay. So I think that's up and defaults. Okay. So I'm going to hide that. So the problem is, watch what happens when I start to move this around. Once it's stretched out, you notice that while the main rig is probably like 2/3 of the way towards the end control, the reference control has already reached the end here. So the problem is that it doesn't account for the stretching that's already here. So I want it to reference the fact that when the tentacle is stretched out here, I want the movement here to reflect the movement here. So the way we're going to do that is get this back in. So I'm actually going to take these two controls here, bring them into the node editor. Now I'm going to take this direct connection that I have here and get rid of it because I don't need it. So what I actually want to do is I want to take the relative distance between the two end controls here and take this movement and I want to say divide the movement here by the distance between these two controls. Well, we just so happen to have this distance tool here that we had previously, and we had a series of nodes that connected it all together. So, actually what I'm going to do is I'm going to just expand the connections for this. So I should think that this gives us the variable of the division. So this is the local distance here. You could use the local scale as well. I know we have it in multiple spots. So this is actually for the other squash and stretch, so we might as well use this one. So this one takes the distance of this and divides it by the default value, which is multiplied by master control icon for the global scale. So this should give us a value of 1. And when it increases, it'll increase that value of 1. And that is what we're going to use to essentially divide the translates here so it corresponds over here. So I know that sounds a little complicated, but I'll show you what I mean. So I'll bring these two back in. Hide these. So what I'm going to do is take the squash control over here. Excuse me. And so what I'm going to do is I'm going to create a, let me bring this in a little bit so you can see. So I'm going to create a multiply divide node. And I'm going to take the translates here of the main control icon for the middle of the tentacle there. And then I'm going to take the output here. Actually, I'm going to take just the output X, since it's only one attribute. And I'm going to plug this into all 3 attributes here. And then, most importantly, I am going to set this to divide. So what this is going to do, it's going to take the translates of this middle control and it's going to divide it by the relative distance of the tentacle. So what that'll do is it'll convert it so as this tentacle moves from side to side, even if it's stretched out, it's going to keep the relative distance from the beginning to the end here. So let me name this really quick. Call this CT tent 1 mid squash. Let's call this adder adjust, multiply divide. And we'll plug this into the translates of that mid control. So now let's test it just to make sure it works. So if I move this out, so now you see this control is getting right near the end and its movement is corresponding here. So this is exactly what we want. The movement on the blend shape is reflecting the movement, the relative distance from the original. So that's perfect. That's exactly what we want here. So now that we've got that figured out, now we can actually plug the distance here into the factor of the squash handles. So what I need here are these two distance dimensions tools. We've got, I think that's all we need for right now. Oh, and the squash handles. So grab these. The node editor, clear it out, add these things in. Let's get rid of main nodes here for the squash handles. So this is all we need. So let's try and organize everything here. All right. Okay, so for each of these, we are going to need 4 nodes. We are going to need the nodes to divide the distance of the tool divided by its original value. And then we are going to subtract 1 from it to get to 0. And then we are going to plug that into a condition. And then we'll have an option for it to multiply it going negative, similar to what we did right here. So we'll go through all of this process. So we get the multiply, divide. Start with that. Make sure I set this to divide. So I'm going to plug the distance here into input 1. I'll call this CT tent 1 low squash local scale. All right. Now we just need to get the default distance here. So that's U right here. So we're going to use our handy dandy tool again. Just quick get at her. Distance, there it is. Okay. We'll plug that into input 2x. Next, we need a plus minus average node to subtract 1 from it. Oops. There we go. So we'll plug this into the first one and do the trick again. Delete that connection. So we got 1 already in there. Set this to subtract. And next we'll need the condition. So I'm going to plug the output 1D into the first term. We'll say if it's greater than 0. This is pretty similar to what we did for the all squash, the other blend shape we just finished. Now we need that other multiply divide. So let me just name this real quick. There we go. Let's get another multiply divide. Call this. I don't know what we called it previously, but I'll call this negative mult. So let me set this to multiply, set it to 2, and I'm going to plug the output 1D into the input 1x here. And all right, so say if it's true, if it's greater than 0, we'll plug this into color if true. And if it's less than 0, we'll plug the multiplier into color false. With that, we can take this and plug it right into the factor. So you can see as the middle control is moving to the end, it's squashing, which is what we want, because this area would be squashing because the controls are so close together. And as we get farther away, it stretches. So that's exactly what we want it to do. So let's just do that for the other side. So I'm going to just take these 4 controls and duplicate them. I'm going to quick call these low, replace with up. There you go. And since the OCD in me is going to hate those numbers at the end, I'm going to get rid of them real quick. Okay. So let's make these connections. Let's do this. Let's try and do this as fast as we can. Distance. Let's get the distance of this. Reload this. There's our number. All right. This goes into the plus minus average. It's already set to subtract since we duplicated it. Plug this into the input 1 of the negative multiplier. And let's grab that condition. So if the first term is greater than 0, color if true, and the negative multiplier into color if false. And we plug the output into the factor. All right. So let's check it just to make sure it works. Perfect. So you can see we're getting the squash when the distance dimension is, or when the distance is getting lower, it's squashing. When we get further, when it gets larger, it's stretching. So that's exactly what we're looking for. So that setup is pretty much done. So at this point, there's still a few things we need to do. We need to create the follicles so that we can connect them into the joints here, similar to what we did on this setup. So let's do that first. Create, oops, nope, do that. End hair, create hair. Should be the same settings as before. Yep. So we delete the output curves, the nucleus, and the hair system. So we're left with the follicles. All right, so the first thing I'm going to do with the follicles is make sure everything is named. So we'll start with the tentacles here. So I'll call this tent 1 mid squash follicles pad, and then we'll actually go through the naming. Now I want the naming to be pretty consistent compared to the other one. So we'll go into the old one here and just make sure we take the proper name here. So SQST2, shape B shape 1 follicle. Perfect. So we'll just go through and name these really quick. Let's keep this going. Go a little bit faster if we can. This is where a script would be helpful, but I don't have a script that would name it this specifically. All right, there we go. Okay, so now that the follicles are named, what we can do at this point is we're going to move them over to the side here, just like what we did in the previous one. So I'll move the U parameter here to 1 so that they're all on the side here. And then at this point, just like we did the last one, we're going to convert the distance from this point to the center of the ribbon and convert that into the scale of these joints. Now, the scale is already connected to the other system for the all squash that we did right over here. So we're going to have to combine those two together. And what I'll do is I'll start it with the end one, like what we did in the previous one. I'll set this one up, and then I have a script to run the rest of them. So let's start with this one. So we're going to take the follicle here, clear all this out. Oops. There we go. So there's the follicle. And similar to what we had, we are going to use a plus minus average node. We are going to plug the translate X into the input 1D because all of these are based on this translate here. And now we're going to subtract 7 because the ribbon is perfectly centered at 7 on the grid. So all we need to do is subtract 7 from this to get the actual default distance here. So we'll do that trick that we did before. We'll plug the attribute into the second one. So we can just set that in here. And we'll mark this as subtract. And we'll call this, make sure we name everything, CT tent 1. Go mid squash 18. And this is local scale. Okay. All right, so that looks good. So we subtracted 7. Actually, this is not the local scale. This is just the subtract. So we'll just call that plus minus average. The local scale is actually going to be this multiply divide. That kind of throws me off. In the newer versions, the plus minus average and the multiply divide have the same icon here, so it kind of throws me off. So I automatically think this is a multiply divide based on the icon. So we'll plug input 1D into the, or the output 1D into the input 1x of the multiply divide. One there. And this will be local scale. All right, now we need to get that default value, which we do by just taking any of the follicles here, reopen the tool real quick, and get the translate X, the actual translate X value. So that's the full value of translate X. So we can just take that now and plug that into input 2x. Oh, we don't actually need the 7 there. We just need to get rid of that. So that's the actual value. We're going to set that to divide. All right. And so the last thing we need to do is plug this into a plus minus average, because right now this is going to give us a value of 1. And, oh wait, no, because it's a scale, we don't actually need that. This will go, scale starts with a value of 1. So at this point, what we can do is take, what I'm going to do is take the follicle here, and then I'm going to take the joint there, and I'm actually going to graph both of them out. All right, so there's the follicle, and where is the joint? There it is. So these are the nodes that we used for the all squash setup. Actually, just to be consistent, I called these SQST2 B shape 18. Want to keep it consistent there. There we go. Okay, so I have this, so the scale is connected by this on-off node that we created. Technically, since we plugged it right into the envelope, we don't really need this node, but what we can do is I might as well just keep it there. Also, the script I'm using to go through the rest of the joints here accounts for this node, so I'm just going to keep it here. So we have this on-off node, and then we're going to combine it with this multiply-divide node. So we got both of these together here, and we're going to throw these into one more plus minus average node. So we'll plug the output X into input 1D0, and the other output X into the first one. And we'll call this call this intent 1. There we go. SQST, I'll call this combo 18. Just so I know that this is the combining plus minus average. Now, the problem here is right now this is adding to a value of 2, and we don't want to have 2 as the scale value on the joints. And I don't want to average it because I want them to, because that would kind of half the scale value between them. So what I actually want to do, all I really need to do is we need to add a third number in here and just set it to -1. So if we plug the output X into the input 1D2 and just delete that connection, we get this third number here. So what I can do is if I just set that to -1, then that's really it. Because now the values are added together, and since they're added together, whatever scale effect is going to be done by either of these setups, it's going to be 100% used in here, and all I'm doing is subtracting 1 to get it to that default value of 1. So nothing really should change here. So if I plug that into the scale X and Z values here, we should see the scale is set to 1, and the scaling should work for both of them. So what I'm going to do now is I'm going to use another script that I built for this. So this is the script we used before for the first squash stretch setup, and this is the second one. It basically does exactly what I just did. It connects everything it creates the nodes, it connects them together, it combines everything into the plus minus average, sets that third value to -1, and connects it into the joints. So it does everything exactly the same. So all I got to do is select the follicles here, select the script, and run it. Tentacle 17. Okay. Oops. I don't know how that one got the name changed. Maybe when I ran the script, something happened there. Okay. All right, well, let's run that again. So select the follicles, select the script, the whole script, and run it. So now if I look at any joint and I pull up the node editor and scrub it out, you can see we have the combo plus minus average node that adds everything together, plugs it directly into the joint. So we bring the polygons back here. So if I bring this out, you see we're still getting the squash and stretch for the main setup. But now, you can see as I move this together, we're getting the other type of squashing and stretching here, the mid-stretch. And it should be working based on the blend shape exactly as we need it to. So, looking good. So we're getting the combined effect of both squash and stretch methods. So the last thing that we need to do is to create the attributes to control the squashing and stretching, just similar to we did for the all squash. We're going to do for the upper and lower squash. So what I might do is, I'll rename that. So I might keep these under one separator attribute, because you probably will just need one on off. You won't need one for each squash and stretch setup here. And then we'll have a multiplier in a position for each of them. Okay, so let's create our attributes. So we'll call this mid squash. And create the Boolean first. So mid squash on off. And then we'll create the other two. 10 to 10. And we'll do upper squash multiplier. lower squash multiplier, and then upper squash position, and lower squash position. All right, so we can start to connect these attributes in. So we're going to take these two squash handles, open up the node editor here. So the important thing that we need are the actual squash nodes here, because these have the envelope in them for the actual squash deformer. We're going to bring this node in and quickly direct connect these in. Mid squash on off, we'll plug this into the envelope of both of them. All right. So at this point, I'm probably going to use the squash handle here. Or I should be able to use the actual node itself. So I want to test to see if that expand problem that I had before is still in there. So similar to what we did last time, we've got the set range here. We'll call this CT101. We'll call this up squash set range. This is for all right, so that is for the upper squash. That's good. Just to double check. So let's open this up a little bit so we can see a little bit better. All right, so we're going to plug the position. We're going to do the multiplier into value x and the position into value z. Remember, the multiplier, or both of these, have a negative 10 min and a 10 maximum. And for the multiplier, we want to use a 0 to 2 min-max. And for the max expand position, it's almost 0 to 1, but it's 0.01 to 0.99. All right, so let's plug these in. I plug out the out value z into the max expand position. That should be good. All right, I think we did this into the actual handle itself. We'll see. Let's see. So if I plug this in to the squash itself, let's see what we get. All right, let's turn this on. So we get that squash. And let's check the upper squash position. All right, so that's working. Looking good. Now the multiplier, I'm going to try and set it to the expand because that was not working for us last time. Let's see if it actually does it here. Ah, so it is doing it here. Yeah, I don't know why it wasn't working the last time. Maybe I tried plugging it into the squash handle itself. But either way, so that might obviously be a little extreme. So what we could do, that worked for when we were setting it up the other way. So what I could do is actually take this down a little bit. Um, eh, let's see. So if I do like 1.5, I'll need the middle to be somewhere kind of in the middle with that. So let's do 0.5. Just so the default is set to 1. So let's see how this looks now. Alright, so that looks pretty good. We get a nice range there. We could even adjust it if we wanted to. So we could say, we could do 0.25 to 1.75, something like that. So if we wanted to push it a little bit further, we could definitely do that. Just make sure that the middle of the min-max is set to 1. Yeah, so that pushes it a little bit further. All right, so that works. So let's do the same thing for the other one. So I'm just going to duplicate this. There it is. And we'll call this low squash. Set range 1. So here we'll plug the multiplier into value x, and the position into value z. All the same settings should be fine because we duplicated the node. So let's plug out value x into the expand attribute here, and out value z into the max start position. So let's make sure it works on the lower side as well. Looking good. And we got the lower squash position working there as well. All right, so we got the mid squash setup pretty much done here. Last thing we need to do is just clean everything up. And that's as simple as just taking everything here and just parenting it underneath that pad. So now, if we take a look at everything, oops, other way. So we now have the 7 blend shapes for the tentacle. So we have all the controlling that we would want for the tentacle. We have different types of setups. We have 2 sine wave setups, 2 squash and stretch setups. We have a coiling setup and a twisting setup and an FK. So what I might want to do before we go is just an attribute to turn the FK on and off, or the FK controls on and off. Should have done that before up here. But I have a script that can reorder attributes, so we can FK, we can call this FK icon viz. There's the attribute all the way down at the bottom. And I can take this control, so this should be the top. I'll just take the pad here and I'll directly connect this into the visibility. So I have to take FK icon viz and plug it right into the visibility. And there we go. We got the FKs on and off. So now we can turn all of this off. We can hide the locators as well. So now we are left with just the main ribbon controls and the icon to control all the different blend shape options here. So I'm going to call the first FK tentacle done, or the first ribbon tentacle done here. So I'm just going to group all the blend shape stuff together. And there we go. So that's pretty much done up to this point. So I know this video is a little bit long, but I really wanted to get the rest of the blend shapes done. And for the next video, I will have all the other tentacles done, and then we can start talking about having a kind of master control to control all the tentacles at once, and connecting it to the center of gravity. So as this moves, it'll move the other tentacles with it. So that's the end of part 4 here. So we'll be moving on to part 5.